Okay, so I actually wanted to start by talking about what's coming up this week, and then for the final exam, we'll talk more about the final exam kind of as we go. But let's kind of talk about the assignments. As far as homework, I am not going to collect any more homework, so no required homework at all because you guys have your final exam next week. So no more required homework. There is a bonus assignment, and it is a large assignment. And I wanted to talk for a minute about how that's going to work. It will be posted to WebAssign. Uh, so this is going to be on WebAssign, and it will be this afternoon. So it will open today, and we're going to say around 2:30 p.m. All right, so it's going to open today. After this lecture, I'm going to go on and set it up. It's already written. It just hasn't been assigned to your guys' section. So just depending on how long this takes, and then I will go in and get it assigned to all of the Math 156 sections. The way the bonus assignment is set up, it is a long assignment. So it's long. It's 85 problems through the semester. So all semester. I'm not like it when I put this together, I did not intentionally leave any major topics out except for this week. So topics are not intentionally left out, but there are some things that are not tested well or not done well on WebAssign, like especially sequence series. So like we're on this last test where you guys had a written part, the stuff on that, it really isn't enough to be studying for the final. So this is not meant to be a complete review for the final, but it's meant to be helpful for the final. So this should be helpful to review for final, but it's not enough for final, but probably doesn't cover everything well enough. And like I said, by that, I don't mean that I purposely left things out. I definitely didn't. I tried to get some problems from each major topic, but especially with sequence series, there's not a lot of good questions that can be done on WebAssign. And like, if you go on there, you're going to notice a lot of them just say, okay, does the series converge or diverge? And I mean, we're all good at doing computer assessments where, okay, you can click converge and, you have 50-50 chance of getting it right. And when you regenerate it, maybe it changes the numbers, but it still is going to converge, or it's still going to do the same thing the original did. So you just have to be careful with that. Like you definitely want to get a decent score on this if you choose to do the bonus, but you need to make sure you know how to genuinely do the problems, because more important than getting a score for the bonus is to do well on the final. And so you need to make sure you actually understand these questions and how you would write and explain what's going on. So just please don't treat it as this is the, if you know all these problems, then you're good for the final. I think broadly that's probably true, but like we really need to be studying old worksheets and old exams. And then if we'll do some review sessions later this week, and I think coming to those will help. But you do want to be working stuff other than just this. So I don't want the focus to be just this bonus assignment, but it should help a lot to review. If I didn't think it would help, I wouldn't have done it. It's not for me to get you to do 85 more problems. I do think it'll help. Just don't make this your only thing that you're studying for the final exam. As far as the way you get credit for this, so WebAssign has its own scoring system. And the way it does it is it's counting like each answer. So, these, even though there's 85 problems, there's probably not just 85 answers. I think there's 100 and some, like, so, it might say converges, and then there'll be another blank where, well, okay, what's the limit? And so you get a point for each of those things. And so you need a minimum score of 80% to qualify for the bonus. And the way the bonus in this class will work is you get the better. So if you get 80% or higher, and as far as the bonus, there's no grade benefit to getting a 99 versus an 81. You just get it if you get over 80%. Does that make sense to everybody? So if you get 80 or higher, you just automatically get this. If you don't, then you do not qualify for this. Obviously, it'd be better to go ahead and get 100% to get ready for the final, but 80% is your cutoff for this. So if you get that, you get the better of two things. You get 2% added to your overall grade in the class. Meaning an 88 is now an A, a 78 is now a B, a 68 is a C, and a 58 is a D. So you would get 2% on your overall grade in the class, or your final exam score replaces your final exam percent, replaces your lowest exam percent. Whichever is better. And I'll automatically calculate which is better for everyone who chooses to do the bonus. So if you do the bonus, I will have two columns in my spreadsheet. One of them will add 2% to your overall score after the final, after everything is calculated. One of them will calculate your grade with your final, replacing whatever your lowest test score was. And then you will get the higher of those two grades automatically. Okay, so you cannot have both of those things happen. And if you do not do the bonus, your final exam does not replace your lowest test score. So you get one of these two things, whichever is better for you. So if you've done pretty well on all the exams, obviously probably the 2% on the overall grade is going to be more helpful for you. If you have one exam that you just really bombed, then the final exam score might be better for you, just depending on how the final exam goes. But like I said, you have to get an 80% on WebAssign scoring system. So WebAssign has to say that you've got 80% or higher. If you do that, you will automatically get these. You don't have to tell me about it. You don't have to pick one. I will calculate both and give you the higher of the two. Now, I'm trying to make this as clear as possible, but I'm sure I did not make it as clear as I could have. So if you have questions, please let me know. Does anybody have questions on how this is going to work?
Yeah, when is this due? Like when is that?
Okay, that's a good question. This is going to close Friday night at 11:59 p.m. So you have all week to work on it. And that includes review sessions. So I think we'll talk more about this, but I think toward the end of the week, what I'm going to do is give you guys pre-recorded videos for the new content and hold live review sessions instead. Because I think do you guys agree? I want to know what you guys think is more helpful. Normally I would want to have the live sessions on the new material. Yeah. And okay, for some reason you guys can only chat to me, but some people are telling me yes in chat. You can chat to everybody now. So yeah, I think what we're going to do today, I might cover a little bit of live material, but we might make the rest of the week me question and answer, and then I will find my old sessions on this material so you can watch them. I'd like to do both, but unfortunately, because of the way my schedule is, I don't have time to run live sessions and live lectures and review sessions. I can do the live sessions, and I might be able to do like one at night, and I will probably do that, and I'll probably even do one this Sunday, and we'll talk more about that. But I think probably what we'll do after today is the live sessions will be review sessions, and I will get you guys the old videos, but the content is the same. I might be talking about a different final exam, but the content's the same. Yeah, so if you get 80% or higher, you will automatically get, so some people in chat are asking this, so if you get 80%, will you get 2%? Yes. So if you get 80 or higher, then you will get 2% added to your overall score, unless the final replacing your lowest test score is better. But if you've done well on all the exams, then the 2% is probably better. Does that make sense to the person who asked that? Does that answer the question? So I'll automatically do the better of these for you if you've done the 80% or higher on the bonus assignment. Okay, the final is not optional. So somebody did ask in chat, is the final optional if we do the bonus? No, the final is not optional if we do the bonus. The final counts 25% of the grade independent of everything else. Okay, so if the final replaces the lowest test score, you get the final exam score for your final exam score, which is 25%, but also for your lowest test score, which would have been, I think, 10%. We'll have to double check the syllabus on that. Does that answer the question to the people asking that in chat? Everybody clear? Okay. All right. Other questions so far, you guys? Okay, that's a good question. So Colin in chat is asking, what's the format of the final? Give me another day or so working on that, and I will be upfront as possible. It is going to be partly on WebAssign and partly written, but I don't know the exact layout of that yet, just because other than deciding that, I haven't worked on the final. But when I have a better idea, I'll let you know. I'm not trying to not tell you. I just don't know yet. But it's going to be about 50% online and about 50% on paper, similar to the third exam. It is comprehensive. The final is on Monday. Originally, the class time was scheduled for 8 to 10 p.m. That's the plan for the written part of the exam. The written part's only an hour, but we'll probably give the 8 to 10 window for you guys to upload and download and things like that. The WebAssign part will be open 24 hours on Monday. Does that work? Does that work for you? I'm okay being a little bit flexible. The written part, we kind of have to do it one time, and that's the 8 to 10 time that the university gave us. They kind of took it off the schedule, but I don't think you guys have any other finals from 8 to 10 on Monday, so I thought that would work well.
For the written part, are we going to get on this Zoom call and have our cameras on?
No, unless you really want to.
Okay, no, I was just wondering.
I don't. No. I mean, same rules as before. Like, don't use electronic resources. We haven't had, there've been a few issues through the semester. Just be careful, you guys. If you use those online calculators, people are getting caught when they do that. It's happened very little, but it has happened. And so it's clear when you guys use the online calculators. Sometimes it's not, but most of the time it is. They do stuff that's weird. And so just be careful. Don't use an electronic thing. If you're, squaring a 6-digit number without writing out how you did it, you used a calculator, so just stuff like that. But I trust you guys for the most part. I trust you guys, period. But there's been very little cheating issues. And so we're going to stick with what we've had. I'm not going to start proctoring.
Are we going to have to square 6-digit numbers?
No, you're not. And so don't square.
Okay.
That has happened. I don't think that's happened in Calc 2. That has happened where somebody did that and didn't write it out. I'm like, well, that's pretty clear what happened there. All right. Other questions, you guys. Oh, my bad. I'm looking at. So, okay. The question is, can we wait until Sunday night for the review session? Or for the assignment? I really don't want to do that. If you have an extreme circumstance, then I might work with you and we'll have you put the extension through or whatever. I understand that you guys have a bunch of different assignments, but the idea behind putting it on Friday is not an advantage for me. I think it's an advantage for you guys where you have a couple days to be working on other things other than just this. I really don't want this to be your only focus for the final. Does that make sense to the person who asked that in chat? So I know this week sucks for everybody. It's probably going to be even worse than finals week because it's dead week. Everything is due at once. But I really think it's better for you if you can get it done by Friday so that Saturday, Sunday, whatever time you have to work on Calc 2 is working on old exams or working on written stuff rather than this online bonus. Because the final's Monday, that means, it almost has to be earlier. If it's an extreme circumstance, I'm sure I will be happy to work with you. And, you can put the extension in on WebAssign just like you always can. And I'll probably just get rid of the penalty, but try to have it done Sunday. Or I'm sorry, try to have it done Friday. All right. Does that make sense? That makes sense. All right. Yeah, no problem. Other questions? You guys good? Okay. And like I said, I will, as I know more about the format of the final exam, I will let you know. Let's write down what we do know. So final exam is Monday. The WebAssign part open 24 hours, but timed when you start, like always. I believe 60 minutes will be the plan for that. And then the written part, we should plan on 8 p.m. So just like on the last one where you had 3 different times to sign up, the plan is to just have one. If you have a serious conflict with 8 p.m., I will try to work with you on that. I'll try to have a makeup version of that. It's just that time is the time that was originally for this class, so you shouldn't have a conflict with that time. But if you do, because it's not on the schedule, of course I'll work with you. But try for 8 p.m. on Monday night to take that. And it'll be designed for 60 minutes. So the plan will be 60 minutes for each part. So 60 minutes and 60 minutes. And we'll give you some extra time for like downloading and uploading it. So you'll probably actually get like 90 minutes, even though it's a 60-minute test. Nobody's going to time you if you spend 70 minutes. Okay, but you've got to upload it within that time frame. Does that make sense? Other questions so far? Everybody good? Final is comprehensive. This bonus assignment does not cover this week's material. I'm not going to give homework on this week's material. I'm going to give some worksheets with solutions. I'll get those posted sometime this afternoon that you can use for practice, but I'm not going to collect them. So I'll get final homework averages computed later this week, and I'll give you a grade update later this week as well. There have been a couple emails saying that maybe some of those calculations were wrong right before break. I'm going to redo all the spreadsheets. So if you think your exam average was a little bit off, I don't know if that's true because I haven't had a chance to check, but I will double check and we will get an accurate number up by the end of the week. I thought they were accurate, but maybe there was a mistake. There have been a couple people saying they calculated something different. And so I will go back and recalculate all of those later in the week. And that won't be today, but a grade update later in this week. Grade update later this week. All right. Any other questions about what's coming up, about what we're doing this week? Okay. So this week's topics. So the last topics. Oops.
Oh, I do have one.
Sure. What's up?
Are we going to have a meeting following the final, or will our last meeting be Sunday night, the review?
Last meeting will be Sunday review session. Yep.
All right.
Yep.
Sounds
Nothing,
good.
no live sessions after the final. We'll talk more about that, but I'll email you guys with final grades and everything, so you'll know all that. But there won't be any meetings after final exam. All right. Any other questions? Everybody good to go? Okay. All right. So the last 2 big topics in the course are parametric equations and polar coordinates. And we never get to cover as much of this stuff as I would like. And so there is definitely more to it than what you're going to see this week. It's a good possibility that you've seen some of this in a pre-calculus course or an algebra 3 course, or I don't know, a trig course maybe before now, especially polar coordinates. Sometimes courses cover parametric equations. So the basis of this stuff is actually not calculus. It's pre-calculus. It's different ways to deal with the coordinate plane than the way we've dealt with coordinate planes up until now. And so the stuff is especially relevant if you're going to go take Calc 3, which is multivariable calculus. So this stuff is used a lot in those classes. These are also used a good bit in physics classes, especially parametric equations. Parametric equations are usually used as vectors, but the ideas behind parametric equations are used a good bit in physics. And so you'll kind of see some of that in these videos. And so, like I said, we're going to have static videos, but I want to give an overview real quick of parametric equations today. And then I'll kind of I'll construct a list of the videos for the rest of the week. And then tomorrow, Wednesday, Thursday, we will have those be kind of review question answer sessions. But these are the two last big topics. And so I want to start with parametric equations. So parametric equations, let's go down here, are something like this. So if I have like x equals, say, t, let's do t plus 1. And y equals t squared minus 3. Excuse me. So parametric equations are when you have x and y defined in terms of a third variable t. And so it's a different way to talk about graphs in the coordinate plane. So normally we're talking about graphs like y equals x squared or y equals the square root of x or whatever it is we're talking about. Here we're talking about x being defined as t plus 1 and y being defined as t squared minus 3. So the first thing we're actually going to do is sketch this. So we're going to graph. And we call these plane curves or parametric curves. So we're going to graph it. And the best way to do that at this stage, not the best way to do it, but a way to do it is to plot points. So we'll make a table. And because of the way this is set up, we're going to pick values for t, and then we're going to find the corresponding values for x and y. Okay, and so let's pick things like t is -3, -2, -1, 0, 1, 2, and 3. And so now, given those values t, we're going to find the corresponding x and y. So if t is -3, what do you think x would be?
-2.
Yeah, -2. So we're just plugging it in. So we get -3 plus 1, and then y is -3 squared is 9, minus 3 is 6. So we get -2, 6. And then if I plug in -2, -2 plus 1 to -1, -2 squared is 4, minus 3 is +1. So we get -1, 1. Does it make sense what we're doing? Everybody good? All right, so we plug in -1, we get 0 for x. We get -2 for y. And then if we plug in 0, we get 1, -3, and then 2, and then -2, and then 3. Excuse me. 3, and then 1, and then 3 plus 1, 4. 3 squared minus 3 is 6. All right. And what did I do? Yeah, that's right. All right. So now we're going to go graph this. And so when you graph it, we graph it like normal. We've got x and y, and we'll have x go 1, 2, 3, 4, 5. -1, -2, -3. We'll say -4 is good. And then y is 1, 2, 3, 4, and we'll go 5 again. And -1, -2, -3, -4, -5. And maybe I'll use a different color to actually draw the curve. Okay, so -2, 6 is not going to fit on my picture. It's up here somewhere. -1, 1, though, is here. So we'll go ahead and graph that point. -2, 6 is up here, but I'm just not going to include it because it's way up there. And then 0, -2 is here. 1, -3 is here. 2, -2 is over here. 3, 1 is here. And then 4, 6 is like way up here. It's like there. And we've got that one too. We're just not going to include those. So then we're going to connect this with the curve because it's kind of following a pattern. It looks like it's following on a parabola here, which it turns out it is. And so we have that. And then I'm purposely not going to put arrows on it yet. But we have this parabola that goes in both directions. Does that make sense to everybody what we're doing? Any questions so far? Okay, so then what we now do is, this is just like graphing a normal XY equation. When we have a normal equation that's X with Y, we call that Cartesian or rectangular representation. This is parametric representation. We're still using XY coordinates, but there's a direction on the curve that doesn't exist when we talk about normal XY equations. So there's a direction as t increases, where are the points going? And so when t is -3, we start up here at -2,6. And then as t gets bigger, we go down to -1, 1, and then down to 0, -2, and then to 1, -3, and then back up to 2, -1. I'm sorry, 2, -2, and then up to 3, 1, and on up to 4, 6. So there's a direction, and we typically put arrows to represent the direction of this curve, and we just kind of put them randomly, indicating that, hey, this is going in this direction. Typically, the way that parametric equations are used is we're talking about motion as time increases. So t is typically the third variable, and that's normally because it would represent time in a practical sense. So as time increases, this is the direction of motion of probably a particle or something. Does that make sense to everybody? What's going on? Any questions so far? Okay, so when you're talking about parametric equations, that is when you have x and y are functions of a third variable called the parameter. Typically the parameter is t, but it doesn't have to be. The graphs are called plane curves or parametric curves. And then what else did I want to say? Oh, there's a direction to the curve. And we call that the orientation. Okay, so there's a direction to the curve, which we typically call the orientation of the curve. So the orientation is what's indicated with these arrows. That's the major difference between just graphing a normal XY equation and a set of parametric equations. But we have an X equation defined in terms of t, a Y equation defined in terms of t. That gets us the set of parametric equations. And then this is some terminology. So the graph is called a plane curve or a parametric curve. And then the orientation of the curve is the direction. So we have plane curves, parametric curves, we want to know what those are. And then the orientation, we want to know what that is. All right, any questions so far? Okay, so the next thing is to kind of figure out how to graph these without just plotting points. So it is important to be able to plot points, but if you have just two random equations, a lot of times there's not a clear pattern. This one I set up so that it would be a parabola, and it would be pretty easy to tell what was going on from these simple values of t. A lot of times that's not the case. And so I want to do an example, and then I want to kind of outline what to look for as far as the videos remaining for the week. So graph this equation by first eliminating the parameter to obtain, and we'll probably do two of these, a parametric, or I'm sorry, a Cartesian equation. And so number one will be x equals, say, 2t minus 5, and y equals 6t plus 4. Okay. Okay, so when we say convert to a Cartesian equation, we mean convert to an equation that involves only x and y, but not t. Eliminating the parameter is a way to, kind of a formal way to say get rid of t. And so the way you do this is I would first quickly think, let's multiply the top equation by -3. So multiply the top equation by -3. Why would I maybe do that?
The t's cancel out.
Yeah, if I add that equation to the equation with y in it, the t's will cancel out. So I have y equals 6t plus 4. And so now if I add those, I get -3x plus y, because those can't really combine, equals 19, and the t's cancel out. Does that make sense to everybody? May have lied, we may do 3 examples of this, but okay, so this is a Cartesian equation, and it would be smart here to solve for y. So I can solve for y and get y equals 3x plus 19. And the advantage of that is now I know what the graph looks like. So that is a straight line with slope 3 and y-intercept 19. All right, and so I'm purposely not putting a scale on these axes, but this y-intercept would be 19, because it's like y equals mx plus b. Does that make sense to everybody? Okay, and now I'm not putting arrows at the end, because what we do need to include here is the orientation of the parametric curves. So if I just graph this, the thing that's missing is the direction. There's no direction to this. It's not like it goes from bottom left to top right or top right to bottom left if it's just y equals 3x plus 19. But when you have a third parameter t, or a parameter t, then there is an orientation. So we're going to make a quick table to figure that out. So we're going to go like we did before and get, okay, t, x, and y, and say, okay, let's see what happens as t goes from, say, I don't know, we'll say from 0 to 1 to 2. And so what happens is t increases from 0 to 1 to 2. And so, okay, I plug in t equals 0 for this, and I get -5 and 4. And then if I plug in 1, I get -3 and 10. And then if I plug in 2, I get what? 4 minus 5 is -1. And then 12 plus 4 is 16. And so -1 comma 16. And so, okay, so -5, 4, and again, this is not to scale, but -5, 4 might be like right in here where the mouse arrow is pointing. And so -5, 4 is there. -3, 10 is further up. Remember, this is 19 way up here. So I could exaggerate this if I want. Maybe I will. Just make it a little bit easier to see. Let's make this a little bit higher. All right, so like -5, 4 might be around there. Remember, this is 19. -3, 10 is further over to the right, but higher up. And then -1, 16 might be like there. And so we're going up and to the right as t increases. Does everybody understand how I'm getting that orientation? So we draw arrows to indicate the direction there. Okay. And so the second one I want to do, we'll do 3 of these and then I'll kind of outline the topics. So the second thing I want to do is this first equation that we did. So x equals t plus 1 and y equals t squared minus 3. So this is the first set we did. And again, now the directions are graphed by first eliminating the parameter to obtain a Cartesian equation. So here, rather than trying to get the t's to fall out, I can solve this first equation for t. I could do that for y as well, but the t squared makes that a lot more complicated. So what I'm going to do is say, okay, well, given this, t is equal to x minus 1. So we see that? Now, what could I now do to get a Cartesian equation, you think? Meaning an equation just in terms of x and y. What might make sense?
Plug in your x minus 1 for the t squared.
Perfect. Plug in x minus 1 for t squared. I could plug it in up here, but I'm going to end up getting 0 equals 0, which is true, but not helpful. But if I plug it into the bottom one, like you're saying, then I would get, okay, y equals, instead of t squared minus 3, x minus 1 squared minus 3. And this is the Cartesian equation. And that isn't the graph, but that's the Cartesian equation that we were asking for in the directions. Does that make sense to everybody? Any questions? Okay, and now to know that we were right about the graph up there, this is y equals x squared, so parabola, shifted to the right 1 and down 3. So we know this is at 1, negative 3. That's a parabola. And you can plot points to make this more accurate. But we can also figure out from the table that we did earlier that it's going around to the right. So table from before gives us the orientation. Any questions on that? Okay. And so then the third thing, or third example I wanted to do is if I have x equals 4 cosine t and y equals 4 sine t. Excuse me. Okay, so on this, it's a little bit harder. It's a lot harder to try to like solve for t, but the technique works here, and it helps that the coefficients of sine and cosine are the same. Although if you look at some more examples, they don't have to be. One thing we can do here is square both equations. Okay, so we get x squared equals 16 cosine squared t and y squared equals 16 sine squared t. And now we can add these. And if we add these, we get x squared plus y squared equals 16 cosine squared t plus 16 sine squared t. And why is that a smart move? Why do you think that's a good idea?
Isn't there a property of like cosine squared plus sine squared
Yeah,
that equals 1?
Yeah, cosine squared plus sine squared is 1. So if I factor out the 16, I can use that. And so cosine squared plus sine squared is 1. So then, okay, x squared plus y squared is 16. And so here is a Cartesian equation that doesn't involve t. It's an equation just involving x and y. And so if we remember from, man, a long time ago, probably, circles.
That's a, yeah, I'll say that's a circle.
Yeah, circles in Cartesian equations look like this. Where the center is HK and the radius is R. So this is a circle with center 0, 0, and radius 4 because it's the square root of 16. And so then we can graph this. And now I am not capable of drawing a circle, but I can draw something close to a circle. And so it's centered at 0, 0, so it's going to go out 4, and I should have made that smaller so my circle looks better. All right, and so we'll pretend that that is a circle. Does that make sense to everybody? All right, and so then we need to get the orientation, and so we're going to do a quick table to get that. And you want to pick not like 0, 1, and 2, but like 0, pi over 2, and pi, so stuff that we can take sine and cosine of easily. And so cosine to 0 is 1, so 4 times 1, 4. Sine to 0 is 0, so 4 times 0 is 0. And then cosine of pi over 2 is 0. And so we get 0, sine of pi over 2 is 1. And then cosine of pi is -1. So we get -4, and then sine of pi is 0, so we get 0. And so we go 4, 0, 0, 4, and -4, 0. So this is going around to the left, so it's going counterclockwise. It's going around that way. Does that make sense? Again, it's supposed to be a circle. Sorry, I'm not capable of drawing that even on my iPad, but that is what it is doing. Any questions on this?
I'm sorry, can you please explain the last part again?
Sure. So it's just as t is getting bigger, what's going on with these points. So when t is 0, we start at 4, 0, which is here. When t is pi over 2, we're then at 0, 4. So you're going from here to here. And then when t is pi, we're going to -4, 0, which is down here. So we're moving in this direction. Does that make sense?
Yes, thank you.
Okay, yeah, no problem. And the idea is actually what happens is as t goes from 0 to 2 pi, we would get one trace of this whole circle. And then when we go from 2 pi to 4 pi, we would get another one. And 4 pi to 6 pi, we'd get another one. So it's just going to trace this infinitely as t increases from 0 to infinity. And actually from -infinity to 0, it would have traced it infinitely as well. So it's going to go around and around this circle forever. All right, other questions? That's good so far. Okay, so what I want to talk about, since we're probably going to stick with mostly now review sessions for the rest of the week, is I want to talk about the major topics to watch for in the videos that I'll send you. The videos are still me, it's just me doing this in a previous semester. So for parametric equations, the big things we want you to be able to do, it's mostly the pre-calculus stuff. So a little bit with calculus that I'll talk about in the videos, but mostly the pre-calculus stuff because we're kind of doing as much as we can do within a week, and we're doing the most relevant stuff for what you're going to need in Calc 3. So we're not covering every single topic with these, but you should be able to plot points, which we kind of did with the first problem. We should be able to eliminate the parameter. And then graph using the Cartesian equation, like the 3 examples we did today, but then there are more examples in the video that I'll send you guys. So there's probably more detailed examples. I probably do some like this, and then I probably do some harder ones that you'll want to look at. And then you want to be able to, given a graph or a description, find parametric equations. So that would be the next big thing we would do tomorrow, but we'll stick mostly with review and question and answer tomorrow. And then derivatives. So dy dx, dy dt, dx dt, and how those are related. And then polar coordinates we're going to stick with how to plot points. Cartesian. Well, okay, so polar coordinates you'll see in the video. And again, the question answer can involve these, so it's not like you can't ask stuff live about this stuff. I just want to kind of keep it open. So polar coordinates are in the form r theta. So you have to be able to convert from r theta to xy, and you have to be able to convert from xy to r theta. So like convert from Cartesian to polar and from polar to Cartesian. So polar to Cartesian here, and then Cartesian to polar here. And then you need to be able to convert polar equations to Cartesian equations. And then Cartesian equations to polar equations. Just these can get very complicated, but the basic examples like what we're doing in the video and like what's going to be on the worksheets that I send you guys. So there'll be some worksheets that have practical problems like this with solutions. And then basic graphs. And you'll see in the video exactly what I'm talking about. And that'll be it as far as what you're responsible for parametric and polar. That stuff is pretty straightforward. Like I said, you're welcome to ask questions, but let me sort through the videos this afternoon and figure out exactly where these topics are, and I will send you a list of what videos to use. That will keep tomorrow, Wednesday, Thursday open for review sessions during our normal lecture time, so you can come ask questions from the homework. If you want to come just work on the, I'm sorry, not the homework, the bonus. If you want to just come and work on the bonus and then ask questions when you have them, that's fine too. However you want to do it. I'll keep it question answer so you guys can structure things how you want to. And it'll be open then that way tomorrow, Wednesday, Thursday. We'll see whether we need that on Friday, and then we will definitely do a session on Sunday. I'll announce the session on Sunday to all sections of the class. The tomorrow, Wednesday, Thursday, I won't announce to the other sections, but if you know people in those and you want to tell them to come, they're welcome to come. But we'll just keep it question answer, and I will be here to answer questions if you have them. All right, any questions while we're all here now? Everybody good to go?
Okay, so besides the videos, is that essentially it for new material?
Yeah, so the videos on this material will be, yeah, I mean, this is way beyond what we covered today. You see what I'm saying, James? So like this is the end of the new material for this semester. These will be on the videos, and then I will get you guys worksheets. My Google Drive somehow had disconnected, so I didn't get them on there at the beginning of this lecture, but I'll get them on there this afternoon. So there'll be worksheets on these, and I'll send you an email outlining this. So that'll be the new material, and then we'll have question answer sessions Tuesday, Wednesday, Thursday, maybe Friday, and then definitely Sunday. And then final is Monday, and that will wrap up the semester. So the bonus, please try to have it done by Friday night at 11:59. But like I said, use the question answer sessions to come work on it. You can sit and work on it and then ask questions as you come across them on there. All right. Other questions you guys? Okay. I think that's it for today. Oh, my bad. Yeah, so I am behind on some emails, especially from this past week. And so the person who's asking that, if you want to stick around, I can talk to you right after this. Okay. All right, you guys, thanks for coming, and I will hopefully see you guys tomorrow for a review session. Thanks.